Good afternoon, guys. My name is Sam Hoodak. I'm a Mastercam Support Specialist here at OptiPro. I'm going to be covering the Mastercam 2023 rollouts for Lathe and Mill-turn. So along with what you see on the screen here, I'm going to be taking an in-depth look here at B-axis contour turning toolpaths and the multiple steady rest support. I'm going to go in-depth with those, and stay tuned to the end because I'm going to be covering some cool tricks with lathe C-axis conversion. First thing on the list here is the addition of subprogram support for Mill-turn with Toolpath Transform. So if you used lathe and mill in the past, you'll know exactly what subprogram support is with Toolpath Transform. Mill-turn in 2023 now has this addition, so you have the ability to output subprograms in absolute or incremental. Another addition this year is the use of active tool planes in Mill-turn for part handling operations. So in the past, you used to only be locked into the left toolpath group or left G54, 55, what you automatically get generated with your job setup. Now it takes the active tool plane and gives you the ability to work off those coordinates. So it just gives you more ability, more power. Mastercam actually used to have this back in the day, but due to user feedback, it wasn't as popular, but now back by demand is the same feature. So if you use this in the past, this may be not so new to you. But with 2023, it now introduces the ability to use G55, 56, 57, or any other work offsets you want to work off of. Another new feature is the ability to use stock preview, and this now resides in the contextual turning tab. So what this does is this offers the option to turn on chucks, stock, tailstock, steady rests, anything on and off with the click of a button. I'll be showing this a little later in one of my demos, but now it's found in the contextual tab and turning, and the other options for stock preview is available in the Toolpath Manager by right-clicking and finding those in those options. So brand new to Mastercam 23 is the new stock preview button in Mill-turn and lathe. So the first big thing that got added this year is going to be multiple standalone, multiple tandem steady rest support. So last year, 2022, introduced steady rest support. Now we're going a little farther here, being able to command multiple steady rests. What I want to do is I want to go into a couple demos here using this. So I want to show you guys how to do that. So my first example here is going to be using multiple standalone steady rests. What I want to do is I want to add support before I turn the ends of these parts here. So if I select everything, you're able to see I have a couple sets of turning operations here that I'd like to add some support to. The new button resides under here. This should be the same as last year, but now we have a couple other functions. So what I want to do here is I want to add some steady rest support. First thing I have to do is unclamp the left. I'm going to then unclamp the right. I want to move the left to a position, so I'm going to go linear. I'm going to move linear relative to my left machine group. I'm going to click the position I want to be at. I'm going to be in point B and hit the green check. From here, I'm going to close my left spindle. So I'm going to go left, clamp, green check. I want to do the same thing with the right spindle. So I want to add steady rest support to the right spindle. So I'm going to click my right steady rest, move linear relative to my right, my G55. And I'm going to go click my position and click my point there. Numbers look good. Hitting the green check. I'm going to go steady rest again, clamp that right steady rest. And what you'll see here in green are our steady rests active. So this should be what you should see every time you want to use your steady rest. So these bright green boxes. You can turn on your stock preview. Seeing a couple different things in here. You can see where our material is, our part, our spindles. Looks good. So I can now generate my tool paths again. You'll see now when we do these, We have some support, which is awesome. That's what we're looking for. I've also added a turret park here. So what I'm doing is before I start my part handling operation, before I go into my pickoff, I'm able to go in and park my upper turret, my B-axis turret head. So now I'm going to go into my pickoff operation. I'm going to go to left spindle, moving from left spindle to right spindle. I'm able to use my steady rest now. I can use my steady rest to pick off and move my part. So I'm going to position my left steady rest. I'm going to go left, pick my position. My first position is going to be point A. I'm going to go steady rest right, choose my right position. Right position to be point C. Now the reason why we're using point C is to make sure that we don't collide with both of our steady rests. If I had chosen point B, that would have ended up with a collision. So that's not so good. So what I want to do now, after I've done that, that's all I have to do is hit the green check. And what you're going to see is the part is now transferred. We both have our both steady rests active on the right side. So everything looks good. I can now go into my sync manager next. So I can go to my G1 button after I pick all my operations. So pick all your operations first, hit G1, and we're going to bring open the sync manager. Now, for those that haven't used Mill-turn yet or haven't seen Mill-turn, what the sync manager enables me to do is sync my toolpaths. It also is how we're going to launch our machine simulation, but I have to sync first. So the first thing I'm going to do here is go right click, expand all. Now my first operation here is I want to go to the end of my operation 7 to the end of my operation 6. And right after that, I'm going to go to the end of 8 underneath that sync on 6. And what this does is this ensures that both steady rests are clamped while the spindles are running. So that's that first set of sync codes I want to do. Next set is I'm going to go to the beginning of 16. So I'm going to go to the align function, and I'm going to go to my 15 here, the end. And what I'm doing here is I'm making sure that when we reposition to prepare for the pickoff move, I'm making sure the steady rests are in position before the spindle sync begins. Lastly, I'm going to go to 23, the top of 23, go to the top of 24, and I'm going to go to the bottom of 23 and go to the bottom of 24. And what these do is this synchronizes everything for the pickoff. So I'm making sure I reach both points before I move the spindle home and move the steady rest along with it. So this is what we're looking for. So I'm going to hit the save button here next. I'm able to launch. This is going to launch our full machine simulation. We're going to see our machine. We're going to see our tailstock, chucks, anything that's included in our machine, our controller, our housing, the whole kit and caboodle. So if I launch this now, I grab this, we're able to see our full machine. So I'm going to get rid of the machine housing. I can get rid of my axes too. I'm able to go in here and hit the play button. And we are going to see our part supported, and we're going to have turning operations done. And we watch our pick off and move to the right spindle. So that looks perfect. Gonna get out of here. Gonna get out of here. And I'm gonna go to my next example. So my next example is gonna be the use of a tandem steady rest. So very similar, just one arm that holds two grippers. So the process is a little different, but the idea is still the same. So what I want to go in here to first is steady rest. And just like last time, I want to unclamp the left, and I want to unclamp the right. After that, I want to move my left linear to the position I want to be at, which is point B. Hit the green check, and then I want to clamp my left spindle. So if I go to stock shading, we can see our geometry, everything looks good. So I'm actually good for this part. I'm going to hit the generate option now, and we can see our tool is now supported when we turn. And I'm going to start my pick off here. Now, given the different setup, we're going to see a different set of operations. What I mean by setup is, again, standalone, multiple standalone, tandem, multiple tandem. They all have different options that are included. In this case, with the tandem, we have one operation to move the steady rest. So I'm going to go steady rest left, pick my position A, and hit the green check. So now the part's supported completely before I move it to the right spindle. So what I want to do here is make life a little easier for ourselves. So what I'd like to do is I'd like to export these tool paths so that I can use them freely whenever I decide. So if I export, they're going to save to our tool library or operations library under 2D high-speed tool paths upper turret. I can hit the plus here. It's going to take a second. Once we get done with this, we are going to see that we now have these operations to use whenever we'd like. So when you're doing a lot of steady rest operations, this is something we'd recommend here. Exporting tool paths, and this doesn't necessarily pertain to just steady rest. You could do this with a set of tool paths for a family of parts. Would also be a great idea. Like if you have to face rough finish pretty frequently, why not export those tool paths? If you're always face rough finish every single time, export those tool paths, import them in whenever you have to do this family of parts. Or if you do them all the time, it's good for that as well. So I just clicked on the 4 operations exported successfully. So I can exit out of here. And I'm going to go where this red marker is. I'm going to go right click, import. I'm going to go to 2D high-speed toolpaths, upper turret, click on 19, click 22, hit the plus, and we're going to see both of these, or all 4 of these operations import. You get a little notification saying 4 operations imported successfully. Looks great. Now we're just going to go through these steady rest operations. So very similar for the right spindle. I want to go make sure my mill-turn steady rest right is unclamped, green check. Going to make sure my left is unclamped, green check. Going to move my right steady rest linear to the new position relative to the right spindle, my right work coordinate system. So I'm going to click here, click my point position C. Again, linear, green check. Go to my parameters here, clamp, make sure it's the right side. So clamp right, and again, if you want to be for safe measure, pick that right spindle group. So I'm going to click the green check again, and now you see we're supported on the right. I can now generate this tool path, and it looks good. I want to select all my operations again. After I've selected all my operations, I can hit my G1 button. Wait for my IOF to load. I'm going to go right click, expand all operations, and I can start my syncing again. So what I want to do here is I want to go on my approach for 5. I'm going to go to the end of 4. I'm going to go to the end of 5 and go over to 4. And this configuration will ensure that the steady rest is clamped before the tool approaches and remains clamped until the tool retracts. What I'm going to do next on 18 is, again, the beginning of 18 to the beginning of 19 and the end of 18 to the end of 19. And again, this is getting ready for that pick-off. So I'm making sure that I'm in the right position for my tandem, and then I'm making sure my spindle's clamped, and then the spindle, my right spindle, is going to return home with my tandem steady rest. Lastly, I got to add 2 more options. So I'm going to go to the top of 20 to the the end of 24, and then the end of 20 to the end of 24. And this sync number 5 will ensure that the stock is supported when the spindle sync is canceled. And my sync number 6 will make sure that the steady rest will not unclamp until the turning operation is finished. So I can hit the save button and I can launch. So just like before, we're able to see our machine. I'm just going to get rid of the housing and the axes, and we can see our machine again. I'm going to play, and we're going to see the same exact thing, just with a tandem steady rest. Looks awesome. All right. So next subject I want to talk about is the new B-axis contour turning toolpath. What this does is this gives users with a 4th and 5th axis capability of tilting to make a toolpath that tilts the tool along a curve. So this is a finishing toolpath, and I want to cover the 2 modes that are used with it: automatic tool axis control and manual tool axis control. And we're going to take a dive onto a part that does some ID and OD turning with some B-axis involved. So what I've got here is this part. We've got some grooves to tackle on the inside, some tight to reach areas on the top. So what I want to do here is I want to go into these toolpaths, and I'm going to stick with the turn profiles just because they're a little easier to use, a little easier to see. So my operation is right here under B-axis contour turning, and I'm going to start with the inside chain first. So what I'm going to do here is pick the tool I want to use, which is going to be my tool 1. First thing that has to be noted is you have to make sure that under parameters, you're using center compensation. It has to happen for the machine control to know where the tip is. So we have to have tip compensation set to center. Next thing I want to do is hop under geometry, and just note that you can leave stock in X and Y, X and Z, I'm sorry. Your compensation direction is already there. You can repick your chain in here. Next thing is going to be our lead in. So I want my lead in to be left. I want my lead out to be in at an angle. And then you'll see that there's length under both of these. So these are the length of your lead in and lead out. Next thing is our basic motion control. And this is where our automatic and manual control lies. We have our tool angle limits, and I have it set to 0 and 180. Take note of this for now, because when we go into the toolpath here and I hit the green check, toolpath's going to be good, but it could be better. Problem is we might see that our tool holder rubs a little bit on our ID. Not so good. So I want to take a look at that and how we end up editing this. So as our tool comes into play here, we're going to see that we're going to get a little bit of rubbing here, and it doesn't get in all the way. So that's not so good. Let's address finishing this toolpath up. So what I want to do now is go under the parameters again. I'm going to stick in this window, and all I have to do is give myself a little bit more room to turn. So I'm going to make my minimum angle limit minus 15 degrees. So I get out of there, I hit the green check, I'm regenerating. And now I get a toolpath that's much more functional. So as we play along here, we'll notice the tool tilts along the axes. Looks pretty good. Gets inside nice and clean. I'm happy with that. So I'm going to hit the green check. Let's do one on the outside now. So I'm going to change my tool. Again, just driving that point home, we want to make sure our tool compensation is set to center. I'm going to jump down here. Notice our compensation direction change. Looks good. My lead in is going to be going to the left. My lead out is going to be going back up. Whether it's at 90 or 45, that's up to you. And then I'm going to go back into here. I'm going to change my minimum to 0 just to keep it standard. And I'm able to hit the green check. If I go watch this toolpath, we'll see that it does an okay job. The problem is that we end up using the full front face of the insert. So we could tweak this in a little farther, but I'd like to take the time to show you how to use the manual toolpath control, which is going to give us the utmost capability to tell our tool where exactly it needs to be. So I'm actually going to take both these toolpaths in this group. I'm going to copy paste them down below. The setup for these is perfect. I don't have to change any of that, but I'm going to add a couple more things. So if I go into the parameters page here on my inside diameter, I'm going to change my tool axis control to manual. And from here, I get the option to select stuff. Now I'm going to show you exactly what we're going to select. If I hit the modify selection button here, I'm going to turn my levels on, and I have some pre-made manual tilt lines here. So what I'm going to do is I'm going to select these manual tilt lines on the inside of this diameter, and I'm going to hit end selection. I'm going to go back to my B-axis toolpath and go green check. I'm going to hit the regenerate on this toolpath alone, and we're going to see how much different the toolpath motion is in here. Now, the automatic was good, but this is going to be better. This is going to be more controlled. So as I'm watching this toolpath go, you can see the tool rotate along using these tilt lines as synchronization points of where the tool has to be in the toolpath. Looks a lot better. I want to do the same thing with my outside diameter. So I'm going to go to the manual control. I'm going to click my modify selection. And I'm going to pick these points. Again, these act as sync points of where the tool should be during different points of the toolpath. So when I hit the green check here, I'm going to remove my tilt lines, and I'm going to regenerate this toolpath. So when I watch this toolpath again, we're going to see that the tool tilts much better this time. We're not using that front edge of the insert anymore. It's rotating along the toolpath. Everything looks great. So that's B-axis turning using the automatic and manual toolpath modes. Now, this last thing I've got here is not necessarily a new function, but this is a phenomenal way to get around some problems. So in this scenario, I've got a multi-axis deburr that I cannot output in C-axis. The problem with this is on a lot of lathes and mill-turns, we're going to have the issue of stroking out an X or Y or both. And I'd like to show you how to make a toolpath that cannot be turned to C-axis immediately into a C-axis toolpath. This is something super helpful for a lot of lathe and mill-turn users. In any situation, you cannot get C-axis output. So I'd like to cover something on this. What I've got here is a part, and this part is a really large diameter part. I believe it's 14 or 15 inches. I've got a multi-axis deburr already set in place. Now the problem with this, just to show you that I'm not lying, I have no way to output this C-axis toolpath, or this multi-axis toolpath, this deburr, as C-axis. So if I play this, even if I set simulate rotary axis to enabled, we're going to see that the tool moves in X and Y. The part is static. Well, this is a problem we're going to probably stroke out pretty quickly here. So let's take a look at how to get this to actually output as C. So the first thing I want to do is I want to go to the very end of this operation. I'm going to let this finish up here real quick. And what I can do here is I can hit Save Toolpath Geometry. Now the key here is to let the toolpath finish. It's going to make whatever wireframe is here, whatever this toolpath shows in NC into wireframe. So if I hit the green check, here, I blank this toolpath out, and I go to my levels, and I enable level 2, my backplot geometry. When I click this, this should look awfully familiar. So this NC has been converted into wireframe, and I'm able to use this at my free will. So if I go to my toolpaths page again, I'm going to go into milling contour. I'm going to start here with my green line, and with my red, hit the red arrow, and then hit the blue arrow. I'm going to do the same thing again for this tool. Hit the red arrow, hit the blue arrow. Green check. So what I get to do is go to my tool page. I'm going to stick with my lollipop that I used before in my deburr. I can go to setup, and I get this C-axis face option in here. Perfect. I'm going to go to cut parameters, turn my compensation off. So what this does is I don't have to compensate this toolpath out any farther. It's already been programmed for the tool. So I don't have to add any further compensation. So I'm going to keep this to off. My lead in and lead out is going to be off, again, because I already had one made from the previous toolpath. I can just go to linking parameters, ensure that what I've got is correct. I'm happy with this. And I can hit the green check. So now what I'm going to see here is a toolpath that should look very similar, if not exact, to Deburr. And when I play this toolpath out, I'm going to see C-axis movement. Looks awesome. So my name is Sam Hoodak. This has been the Lathe and Mill-turn presentation. My contact information is shoodak@optipro.com, or if you want to reach any of us, it is mastercam@optipro.com. We're here practically 24/7. You guys have a wonderful afternoon, and thanks for joining me.